Lesson 1.1, Functions Review. The goal of this lesson is to determine whether a relation is a function and then find the domain and range of that function. So let's recall what a function is. A function is a relation where each input has only one output. Right? This will be more formally defined in the lesson note. But each input has only one output. My typical example to describe a function is like a pop machine. If you press the Sprite button, you better be getting back a Sprite, right? If you press a Sprite button and it's a 50% chance of getting Sprite and a Coke, well, that's a problem, right? It's not a very good pop machine. There could be two Sprite buttons, that two different buttons both give you Sprite. That's okay, right? That still serves purpose, that's still reliable. But if you press a button and you're not sure what you're going to get as your output, that is an unreliable machine and it's not a function, okay? And the domain and range, the domain is all your inputs in set notation. The range is all your outputs in set notation, okay? So those are kind of your quick definitions as we do some examples here. So determine whether the following are functions and state the domain and range for each, okay? So to look at a graph, there's kind of one primary example we use to figure out whether a graph is a function. And that's by using the vertical line test. The vertical line test states that if there's a place that you can draw a vertical line on your function and it passes through more than one point, it is not a function, right? There can be no place where I draw a line and it passed through 2 points. It does get a little bit interesting here, right? You can see that it almost is vertical, but throughout that time, it looks to constantly be moving right, even though it is pretty steep. So I'm going to say this is a function because it passes the vertical line test. Now, in terms of the domain and range, we're asking ourselves, okay, what x values are possible for this function? Note that we only see within a certain range, right? We can't have an infinite graph, so we can't see all the x values. But here, because of these arrows arrows indicate that it goes on forever in either direction. So our domain here is XER. X is an element of the real numbers, so x can be any number, essentially. Now, the range is a little bit more interesting. We don't see all the range, right? Because it doesn't reach here from our knowledge. But again, these arrows indicate that it goes forever down to the left and forever down into the right. There could be an asymptote, right? This graph looks like it's approaching an asymptote, but the asymptote is not drawn in for us. And because we don't have the equation of this function, we can't assume there's any asymptotes. Right now, it looks like it's going down and to the left and up and to the right. So any y value is possible here because it's going forever up and down. Okay? So that's number one. Number two, we are given an equation, x squared plus y squared is 25. So you have a couple of options here. You could either make a sketch of this thing, right? And now you're probably thinking, okay, how do I know what this looks like? Well, this x squared plus y squared is 25. Hopefully reminds you of the distance formula, right? The distance formula is x squared plus y squared, which tells you the distance that any point has to the origin. So here, the distance, this function is all the points with distance 5 to the origin, which ends up just forming a circle. Right, so essentially you're going to take the square root of this number, and that is the distance that all these points have to the origin. So we know from the sketch I just drew, that it is not a function, but we don't actually need to graph this thing. In order to prove it's not a function, just give me an input that has two different outputs, right? If x equals, let's say, 0, right? Well, y squared would be 25, but then y could be positive 5 or negative 5 in that case, right? So if x equals 0, we get two possible answers for y, which means this is not a function. Okay. Now, in terms of the domain and range, graphing definitely helps here. We can see it's going to be between our negative 5 and 5. There is a way to find this from the equation as well, right? Squares can never be negative, right? So because y squared the minimum it can be is 0, x squared must be, less than or equal to 25, right? And if x squared is less than or equal to 25, that must mean your x has to be in between -5 and 5, right? Anything bigger in either direction would make x squared larger than 25, and because y squared can't be negative, that means your total must be greater than 25 as well. So that's your domain, and we can add the XER at the end. Your range is going to be the exact same thing. -5 is less than or equal to y, is less than or equal to 5, YER. Okay. Now, these next two examples are a little bit more straightforward, right? When you're given discrete functions like this, which are not continuous, they're just a series of points, your function, you're really only asking yourself, is there an input that has more than one output, right? So here, 2, 3, 7, and 9 each have one input, so yes, it is a function. Your domain is all your inputs. Again, here, saying XER is a little bit redundant because there's only 4 values that x could be, and we just listed them. So it's cool to just say this right now. And same with our range. Our range here is actually only going to be 5, 8, and 10. 4 is listed here, but there's no x value that could give us 4. So there's no point listing 4 in our range because it's not actually one of our possible y values. So our range is just 5, 8, 10. Now this one here, hopefully you can see it is a function, right? There's no input that produces more than one output. Your domain is just all your x values. So you have -3 and all the integers up to 3. Your range, this is where the range gets a little bit interesting, right? Because they start to repeat, so we only need to list each one once. 1/8, 1/4, 1/2, 1. Right? There's no need to list 1/2 again because it's already in our range. It already is one of our possible y values. So although there's 7 points, there's only 4 possible y values. So that is your quick summary of lesson 1.1. Hopefully that gives you enough of a head start to try some of those questions.